In this video, I'm going to show the problems the Apollo 14 crew had with the initial docking between the command module and the lunar module, which nearly resulted in another aborted attempt at a moon landing, coming not long after Apollo 13's problems. If you need a recap on the operation of the docking system, I've put a link here. Apollo 14 was crewed by Alan B. Shepard Jr., Stuart A. Roosa and Edgar D. Mitchell. Al Shepard, the first American in space, was grounded after his first flight due to Meniere's disease, which is a disorder of the inner ear causing dizziness and tinnitus. He went on to have experimental surgery, which later restored his flight status in May 1969. With his rookie crew, they were selected for Apollo 14. Stu Roosa was the command module pilot and was keen after many hours in the simulator to do the most efficient docking yet. This he would have achieved if the docking probe had worked first time. After Apollo 13's aborted attempt at landing on the moon, all eyes were on NASA and Apollo 14 to make a successful problem-free trip. Apollo 14 launched without incident on the 31st of January 1971. This was 9 months after Apollo 13, which gave the engineers a chance to rectify all the problems encountered on the previous mission. Everything ran smoothly, and after entering TLI, translunar injection, the command module separated and initiated the docking maneuver. This was approximately 3 hours after launch. Stu Roosa guided the command module using the RCS, the reaction control system, a textbook approach using the minimum amount of fuel. The system is designed to capture with closing velocities of between 0.03 and 0.305 meters per second.
And we docked.
Unfortunately, Ed Mitchell's call was premature. Stu added some thrust and a second attempt was made. Still no latching. A third attempt. This time, when contact was made, 0.55 seconds of thrust was applied to hopefully force the probe head home. Still no latching. Finally, a fourth attempt, this time with 1.95 seconds of thrust on contact. Again, without success. Another attempt was made, this time with a faster velocity. And again. These attempts relied on the forward velocity and no extra thrust was applied on contact. At this point, they back out and discuss possible solutions. They verify the docking probe circuit breakers are all on and the probe extend retract switch has shown the correct indicators. All these are okay. With the switch set to extend, Houston asks them to try the docking again. This time, Houston advises that when contact is made, 3 seconds of thrust is added. The actual amount of thrusting was 6.2 seconds, but still no joy. Stu Roosa reports that he can see scratch marks on the drogue about 1.5 inches long, 120 degrees apart. The latches should retract when entering the drogue head, but the scratch marks are indicating that the latches are stuck out. Once again, they check the retract switch, which is indicating grey, and the nitrogen bottle will not fire to retract the probe. This tells Houston that the capture latches are cocked, but there is something stopping them from being released. If we look at the cutaway, you can see where the latches enter the drogue. They are depressed, which pushes down on the spider. Then, when they go through the top of the drogue, they spring out and lock into position. Something seems to be stopping the spider from moving and therefore the latches are staying out. Houston then advises them to go to extend release and hold it for 5 seconds. Then return to retract and try the docking again. Again, without success. The time elapsed since the initial docking attempt is 1.5 hours. Houston now has a docking probe brought into the control room, and astronauts Gene Cernan, John Young, and the engineering team discuss possible solutions. At this point, it is looking more and more likely that they will have to do some hard suit work. This involves all the crew being fully suited up and then opening the spacecraft up and retrieving the probe. This they would then bring into the command module, which would allow them to do a close inspection of the latches. However, this would be a last-ditch attempt to try and save the mission. If they can't dock with the lunar module, then the moon landing would have to be aborted, and after Apollo 13, it would be another high-profile failure for NASA. To try and avoid this scenario, Gene Cernan comes back on the comms with one final idea. He asks them to go ahead and go through a normal docking procedure. Once there is contact, keep a +X. This means continue thrusting, which should help with the alignment. Then, blow the nitrogen bottle and retract the probe. The probe, once retracted, should enable the lunar module to connect with the command module docking ring and get some latches. They are hopeful that even getting one latch should be enough. The rest of them can be done manually from inside the spacecraft. One problem they envisage, though, is that electrically there might be a series path that stops them from actually retracting the probe. It seems the thoughts in mission control were that the probe would not retract, but they felt they would rather attempt this first rather than go into a hard suit scenario. They start the 6th attempt.
Houston, we're about 12 to 15 feet away.
Roger, Ed.
Contact. They attempt to retract the probe without success. Stu Roosa continues applying thrust. Then, after 6.9 seconds, the latches depress. The probe retracts, and then 5 seconds later, latching is successful.
Sorry, Doc.
Roger, Al. That's great.
Super job, Stu. Thank you. It didn't even wiggle when he hit it.
Once the tunnel was pressurized and they could remove the hatch, they found all the latches had activated. Just 2 needed a slight push to lock them in place. The crew then continued on their mission. Instead of jettisoning the probe and the lunar module, as would be the normal procedure, the probe was returned to Earth so the NASA engineers could do a thorough investigation on it. During the probe inspection and tests, various particles were found, but none large enough to stop the mechanism from working. The focus was therefore on the items that could influence the position of the spider. If something was impeding the travel of the spider, then the latches could not depress and go into the locked position. There was talk of various foreign materials in the probe head. I've shown it here in this diagram with ice, and you can see how it would prevent the spider from moving. The conclusions were that either a foreign material that was subsequently lost, restricting the mechanical operation of the probe, or jamming of the cam. Therefore, on subsequent missions, cleanliness was increased, a cover was applied to the probe head prior to launch, and there were design changes to the cam. On Apollo 14, and indeed for the rest of the Apollo missions, the docking mechanism performed flawlessly. And as they approached the moon for an historic 3rd landing, Al Shepard made sure all the essentials were packed for the lunar surface.
Miles and miles